Hey there. Before exploring machine learning algorithms and data science projects, it is important to learn a few libraries that are very much needed for programming. As part of that, we shall learn about Pandas today. Yes, I know what you are thinking. Pandas. Are we here to watch cute panda videos? I wish, but no. Today we are talking about the Pandas library in Python, and trust me, it is equally adorable, but in a programming way. For anyone dealing with the data, Pandas library is as lovely as the animal. Let's start Pandas with a little story. Imagine you are in a massive, never-ending supermarket called DataMart. All around you, there are rows and rows of data. You witness huge amount of data. Everywhere around you, mostly unorganized. And you are there, standing clueless, holding a tiny shopping basket, wondering, how on earth do I find what I need in this mess? Well, my friends, that is where our superhero comes in, Pandas. He helps you find what you need among the infinite rows of data. So Pandas is a powerful data analysis and manipulation tool for Python that will help you find, clean, organize and manipulate the data like a pro. You could say Pandas is like that one friend who cleans up your room and then help you find your lost things, if your lost items were actually a data. Okay, forget that. Here is the real deal. Pandas gives you two magic tools, series and DataFrame. Think of series as a single column like a shopping list, and DataFrame is the entire grocery cart, a table that can hold multiple columns of data. So basically a series is a column and a DataFrame is a collection of those columns. Want to slice and dice your data like a chef? Pandas has you covered. Need to find all the people named John who bought bananas on a Tuesday? Pandas can do that, and it won't ask why you need to know. Imagine asking your friend, hey, can you find all the people named John who bought bananas on a Tuesday? They would probably look at you like you have lost your mind. But Pandas will do it without judgment, because it's a library, and libraries are cool like that. Now let's create a series and DataFrame, because talking theory is like watching a cooking show and never tasting the food. I am not here for that kind of torture. Here is how we do it in Python. Folks, first import Pandas. Import Pandas as PD. Pandas, of course, is too cool to use its full name. So we just call it PD like we are best buddies. Let me create a series of number of fruits at a store. Number of fruits is equal to PD dot. We are calling our best buddy Pandas and ask for series. 15, 22, 30 are number of different fruits. Print number of fruits. We have defined a series. You can observe one more column appeared with 0, 1 and 2. This is the index, unique reference for each of the values in a series or in the data frame, just like we had index in the string or list. The index in a Pandas series is like a name tag. It tells each value who it is. You can even rename them. So let us make changes while defining itself. Add index is equal to list of apple, banana and cherry. Printing it again. Now our series has become something meaningful. Want to have more fun? I will rename the existing index with a new list of index using number of fruits, our series name. .index is list of fruit images. If you are using Windows, use Windows key plus semicolon, and in Mac use Ctrl plus Command plus space to open emojis picker. I will add emojis of different fruits. Print series again. Now your series is fruity and fun. Now let's create a data frame. Name of data frame is df. Name whatever you want. Data frame must have multiple columns and each column must have a column name. Our data frame has 3 columns: name, age, and favorite food. Each column has 4 rows of data. Names we have are John, Jane, Jake, and Jill. All have names starting with J. What a coincidence! Data we have in age and favorite food are these people's age and food they like, respectively, in the order. Let us print this data frame so that you get a better idea. We have got ourselves a data frame. John is 28 years old and like pizza, and so on. So information is printed in the tabular form. Okay, now that we have cooked up this tasty data frame, let us learn how to slice and dice it like a professional chef. But no crying over like slicing onion here, only joy from data slicing. Want to grab a specific column? Easy, df with only name. And we get a series of names, just like you had to call out roll in a classroom. In the real world, data isn't as tiny and neat as 4 rows of hand-typed information. It's a wild jungle of thousands and sometimes millions of rows. Imagine sitting down to manually type every sales transactions, every customer details, and every inventory update. Your keyboard would probably pack its bag and live forever. Thankfully, companies are smarter than that. They maintain all this data in handy spreadsheets, Excel files, or CSVs. It is like having a treasure full of information, neatly organized and ready to use. Instead of wasting time manually creating the data frames, we just import the file in Pandas, and boom, your data frame is ready in seconds. So let the spreadsheets do the heavy lifting while you focus on digging into the insides. So now we read CSV file with Pandas. I am using employee salary data. It is a dummy data with 50 data points. Import the data using pd.readcsv and then path to the file. You need to specify the location and directory where the data is stored. I have stored the data in the home page of Jupyter and hence imported directly. Just like that, we have got a data frame without the hassle of defining all those loads of data. And now you are ready to slice and dice your data however you like. If you want to look first few rows of the data frame, check df.head. You get first 5 rows of the data. And if you want to see more than 5 data points, just mention it. Python is very friendly. It returns whatever you ask for. Now some of you might be wondering, why should I use Pandas when I have got my trusty Excel to do all these jobs? Pandas can handle data so large that makes Excel sweat. It is fast, it is flexible, and it can merge, filter, and group your data like it's a magic wand. Excel is like a bicycle with training wheels, while Pandas is a rocket ship that can take you to the data moon. And no, I'm not exaggerating much. Next up, let's talk about set index. We had the employee data. They have unique reference, employee ID. Instead of recognized by the index like 0, 1, 2, they deserve to be recognized by their employee ID because it is unique. Right now, our data frame rows are indexed by these boring default numbers, but we can change that. Let's make it more personal using set index to set a more meaningful index like their employee ID. So df is equal to df.setIndexEmployeeID. No more generic numbers. Now you can refer the data by the person's ID directly. We have data frame now. We need to extract the information from the data frames. We have 2 data ninjas for doing that, loc and iloc. These are your go-to weapons for grabbing specific rows and columns. But let me tell you, they have very different personalities. iloc is index-based and loc is label-based. iloc is your I don't care about names, just give me the numbers kind of guy. And that's the difference between loc and iloc. Labels versus positions. Both ninjas, both awesome. I will tell you one fun fact. Even the experienced data professionals sometimes get confused which one to use. That is very normal. Let us see some operations. Then you will understand better. Starting with iloc. iloc doesn't care about names. No, this guy is all about positions. You ask for information in any rows or column and he does it without asking questions. iloc reads row first followed by column. Now let's say you are interested in a single row, like you are gossiping about only one person in the group. You can use iloc to get that gossip. I stands for index and loc for location. Want to know about the person sitting in row 1? That's how you get them. So iloc 1 return the data in the index 1. Gossiped successfully, but remember, iloc is all about position. Like in sequence data types, colon is used to mention the range. This line is telling to return all rows and column 1. Column 1 is not first column because we have 0th column. I hope you remember Python had a bad math teacher who taught counting from 0. Here is the output. You can display the range of rows and columns. iloc with the colon 3, 0 return rows 0, 1, 2 and column 0. Next we have loc. This guy is all about labels. He says give me a name and I will find the data for you. He is precise, focused and doesn't care about the position. You can use him to grab the specific rows and columns by their labels. I want to know the name of the person having employee ID E003. Only name. Let me ask dataframe.loc row E003 column name. Okay, I don't get any other information, just with the name. Who stopped us from getting more information? Just write df.loc E003. There we have it. That employee's entire life story right there. Let us give some twist. Get data based on some conditions. DataFrame.loc find data of all person having the salary greater than or equal to 3000 units. We are interested in only those who make good money. These are those people. I am also concerned about their departments. I want to find those people having salary 3000 units and belong to IT department only. And these are our shortlist. In any datasets, there are good amount of junks along with the information. Loc help us in filtering the data and serve us that only we are interested in. Thanks loc. Now let's move to some fun methods. First up, the describe method. The data analyst version of reading someone's entire life story, but less dramatic. So df.describe. Describe gives you all the juicy statistics about the data frame. It is like data's resume. The mean, the minimum, the maximum, everything you need to make judgments. Now let's calculate something simple like the mean age. I mean, why not? df age.mean. That returns average age of our data friends. That means, statistically speaking, our group is pretty young and energetic. Let's talk about uniqueness. The unique function will tell you all the distinct values in a column. Kind of like pointing out all the unique personalities at a party. If you check for unique values in department, you get list of the departments used in the data. All data belong to one among these categories. Let us filter some data now. Like you are filtering your Instagram feed to see only what you really care about. This works same as the loc method. For the previous data frame, suppose we want to find all the people whose favorite food is pizza. Easy. df having df of favorite food is equal to pizza. Now let's talk about merge. This method is like a matchmaker at a party. Its job is to bring different datasets together, like finding two long-lost friends. Suppose you have two data frames, one with names and ages, and another with names and cities. If you see names, they are same. That means there are two data frames belong to same people. Naturally, you want to combine them, right? Who is ready to manage two datasets belong to the same people? That is where merge steps into the play. Create a new data frame, merged df is equal to pd.merge df1 and df2. Based on what should I merge? We need to merge on comparing names because names are same. That displays the merged df. And just like that, the names, ages and cities are all living happily ever after in one data frame. Merge is the master of matchmaking, bringing data together on common ground, in this case the name column. Next we have join. Now join is like merge, but it works more like neighbors sharing a fence. It joins two data frames side by side based on their index. Suppose we have set the index of both data frames to name. Now join them based on name. Joined df is equal to df1 dot join df2. See? Neighbors living side by side, sharing all their secrets in one nice joined data frame. Now let's say you have got two datasets and you want to stack them together, either one on the top of the other or side by side, like building a data sandwich. Enter concat. Here is how you can stack two data frames on top of each other like you are piling up pancakes. pd.concat df1 df2. But if you prefer side by side actions, just change the axis. pd.concat df1 df2 axis is equal to 1. Concat lets you build your data skyscraper any way you like. Now let's check the type of data in your data frame. This is like asking, okay, what are we really dealing with here? Is the age column full of integers? Is the city column full of strings? Let's find out. df.dtypes. We have got integers for age and subjects, a fancy word for text for city. Now we know exactly what kind of data we are working with. Now let's say you want to change someone. I mean change the type of a column. Maybe you have decided that the age column should be a float instead of an integer. Easy peasy and done using yes type. df age is equal to df age dot as type float. Age is now a float, like a number that's ready for some serious math. So if your data ever needs a makeover, as type is your tool. And that, my friends, is your Pandas toolkit. You have got setIndex to personalize your data, loc and iloc to grab specific slices, merge and join to bring datasets together, and concat to stack them like data sandwiches. Now go out there and make some data magic happen. And remember, when you handle tabular data in Python, Pandas is something you cannot miss. Now you must be feeling Pandas as cute as panda, the animal, or horrible like angry panda. With practice, even angry panda turn out to be cute one. See you in the next class.